The objective of this activity is to show experimentally that alternate interior angles formed by two parallel lines and a transversal are equal. Let's understand the concept of alternate interior angles. For understanding this concept, we have to draw two parallel lines. Let the first line be labeled as L and the second line labeled as M. So they are looking parallel, right? And now we have to draw a line which intersects both L and M. Let's mark arrows on either side and name this line as N. This N is known as the transversal. Now, to understand what are alternate interior angles, first of all, we have to understand what are interior angles. All the angles which lie between the two parallel lines are called interior angles, like angle 1 here, angle 2, angle 3, and angle 4. So I have named all the four interior angles as angle 1, 2, 3, and 4. Now, if you see angle 1, that lies on the left side of the transversal in the upper bunch, and angle 4 lies on the right side of the transversal in the lower bunch, and therefore they are known as alternate interior angles. If you draw such a figure and measure angle 1 and angle 4, they are going to be of equal measure. And likewise, angle 2, which lies on the right side of the transversal, will be equal to angle 3 in the lower bunch, which lies on the left side of the transversal. This pair is known as alternate interior angles, and they are equal. Angle 1 equals angle 4 and angle 2 equals angle 3. To perform this activity, we require the following material: a geometry box for drawing purpose, a pair of scissors for cutting work, Fevicol for pasting, and sketch pens. Let's perform this activity of transversal and parallel lines now.
So in this activity on verifying the equality of alternate interior angles, we have taken a line AB and a line CD which are exactly parallel to each other. And we have drawn a transversal EF intersecting AB at P and CD at Q. The two angles which we have shaded here, this is angle 1 and this is angle 2, they lie between the two parallel lines and therefore they are called interior angles. Also, these two angles lie on either side, that means one on the left and one on the right of the transversal, and therefore they are called alternate angles. So the combined name is alternate interior angles. Now we need to verify that angle 1 and angle 2 are actually equal. For performing this activity, you need to take the cutout of this particular angle. So how do you cut this angle? You can cut it like this. So I have already cut it out for you. This is the piece you will obtain when you cut angle 1 like this. See, this is just coinciding with angle 1. So this is angle 1, and similarly you have to cut angle 2. So I have already done it for you just to save time. Here we go. This is angle 2. See, this is exactly overlapping angle 2. So angle 1 and angle 2, the two cutouts are obtained. Now how do you prove that these two angles, angle 1 and angle 2, are equal? For that you need to keep them one above the other like this, and you will find that they overlap exactly. And when two angles overlap exactly, they are equal to one another, thereby proving that the two angles, angle 1 and angle 2, which are alternate interior angles, are equal to each other. And that completes our activity on verifying the equality of alternate interior angles.